Matthew, we've been talking to a lot of facilities who are looking to switch to front row because they've been noticing something new that they don't understand. They've been telling us that their fertilizer is mixing slower and leaving more residue in the stock tanks, even though they didn't change anything in their standard procedures. And we think the trail leads back to sulfuric acid. So let's walk through how that's happening.
For sure. And I think supply chain in general and sulfuric acid controls a lot of the inputs. And so when you look at the current geopolitical situation, given different trade lanes being closed down, wars and situations going on throughout the world, a lot of countries will then protect some of their most important assets, which sulfuric acid traditionally is one of the most widely produced chemicals because of how important it is. But the second that you start having situations that are affecting shipping lanes, the security of other inputs and ingredients or food products and things of that matter, countries will start banning the shipping of that, because what a lot of people don't realize is sulfuric acid controls the manufacturing of almost all, if not the most important of the fertilizers we use. It's used to make, phosphoric acid, and then that phosphoric acid is used to make a tremendous amount of other fertilizers. And then sulfuric acid itself is a direct input and ingredient into making a lot of other ingredients and raw inputs as well. The first thing that happens out of that is then kind of the security of your pecking order and who your partners are and who you're aligned with from both a raw supply standpoint and your input ingredients, and then you as a company from a volume and what industries you serve. So when these things are happening, obviously the most important is protecting food networks and companies that are supplying a lot of ag-based products to the standard ag industry, people growing food.
Got it. So it sounds like it's kind of interesting to zoom into the supply chain here. And if I'm hearing you right, it sounds like sulfur globally is a little tight right now. And what's happened is because sulfuric acid is upstream of a bunch of the things that we need to use to make fertilizer, it's resulted in a lot of agricultural companies and potentially cannabis fertilizer companies not having access to the grade of ingredients that they need. So the supply chain is the sulfuric acid is used both to produce things like potassium sulfate, but also sulfuric acid is used to make phosphoric acid, which is required to make a lot of our main heavy lifting phosphate fertilizers, the things that are really load bearing in formulas. So the monoammonium phosphates, the monopotassium phosphates. So for situations where a company might not have really strong supply chains or access to high quality, are they having to search for other places? Like, what happens when their normal sources start to run out?
When people are running out of their traditional fertilizer sources, they absolutely look to other places. And I think that's going to call into question a lot of the time quality. I think a huge advantage of working with a team like Front Row and our partners is the amount that we buy and the amount of inventory we stock in years in advance. And I think more so our ability with our lab testing and our quality assurance and customer service. When other companies go buy other inputs from other companies, even if they're the same ingredients, those products rarely show up the same. We've had really good relationships where we've been able to maintain, even through shortage in sulfuric acid, buying from the same suppliers and the same raw material manufacturers. But one thing that we're always going to do as soon as their raw inputs change, so we might be buying the bulk calcium nitrate or the bulk monopotassium phosphate and from the best suppliers in the world, but they still need to buy their ingredients to manufacture those products or to create those products for themselves. And as those sources change, I think where our advantage is we use our analytical labs from the start of receiving those raw materials, the beginning of blending, throughout the process of blending, and all the way through the end of blending, to ensure that not only those ingredients we're receiving from the same suppliers are maintaining that quality we expect.
If a grower wants to know where they're potentially exposed, what is the tell? What are the kind of products or the ingredients that are most at risk when there's a supply chain upstream disruption like this?
When your product has changed in any manner from what you've expected, I think the first indication would be is that that deviates from the norm, whether it's in a stock concentrate, a little bit of residual buildup in your tanks. I'd always look at still maintaining my cleanliness and how are my SOPs looking on the water chemistry side and the maintenance of those systems. But the biggest tells for us when we see it in the industry and customers have approached us, it's been more in their actual stock concentrates and seeing soot or buildup at the bottom. And a lot of time these systems on the wicks have filters or they're positioned above the bottom of the tanks, and it becomes not detrimental, but doesn't have severe consequences because it's not necessarily being sucked into a system or clogging a part of the system. Again, when you're looking at sulfuric acid and what products are being affected on the market, we have outdoor growers, especially going into outdoor season, where we sell phosphoric acid as for pH conditioning and alkalinity adjustment. And so many growers that traditionally buy sulfuric acid are either seeing huge price increases or they're not even being able to source it because people are unwilling to come off of it. The next products have actually been potassium blends typically. Monopotassium phosphate, I think, is actually maintained impeccable industry quality. It's just become unbelievably low in availability and expensive over time when you don't have a good priority in purchasing materials. And I think the biggest one when you're looking at formulations, and this is a part where Front Row separates itself in terms of how you get sulfurs and potassium into formulations, is potassium sulfate, potassium nitrate, monopotassium phosphate. They're expensive. They're really high quality ingredients. And at Front Row, we use quite a bit of them to get our potassium source, and we really limit the amount of potassium sulfate that we're using in our formulations. And so when you're looking at industry standard of some of the highest quality formulations, you'd like to see sulfur levels that are below that 7 to 9% range. And there is kind of that gold standard is where you'll find some of the best products in the industry are 7 to 9% in sulfur. And a lot of their potassium and phosphorus are coming from really high quality sources at that point. You get into more of a one-part blend where you're adding a kalinit or maybe adding an MKP. And if it's constructed from a value proposition perspective, you're going to see those blends being in the 11, 14, even 16% sulfur range. And that gives you a lot of insight into kind of how that product's built. That would start being more worrisome for me with how the world situation's looking right now.
When somebody's seen the precipitation in a tank show up, what's kind of like the most likely candidate? Potassium sulfate looks like it might be the most likely because it already has like quite low solubility relative to all of the other components in a tank. And if you have a drop in the quality and the composition of the potassium sulfate, that seems like it could be one of the first things that would start precipitating out. Is that right? Or is it something else that somebody would more likely see first?
No, I think I would always start exactly where you just mentioned. It's even if it was a different type of blend that didn't have potassium sulfate in it, I'd always start at, okay, what's the least solubility when it stands by itself and has the longest solutionizing time? You also have products like calcium hypochlorite that are tremendously soluble, but you can also look up the solutionizing time and it'll tell you, well, yes, although very soluble, it takes long periods of time to solutionize. Potassium sulfates, a lot of phosphorus and other potassium products also fall in that category. But potassium sulfate, yes, is traditionally one of the lower solubility products. And then after that, you're looking at the inclusions. When you look at a fertilizer bag, the numbers on the front of it are the guaranteed analysis. So that's the percent of the weight of that product that is actual fertilizer. And well, very few of those, if any, in the world add up to 100%. So there's other inclusions that from the highest quality manufacturers are 100% water soluble, have no interaction with the plant, and don't contribute to EC or conductivity. But other inclusions, especially when you get into potassium sulfates and some of those lower quality inputs, can be other fertilizer salts. They can be granular material, soils, and just a wide array of different types of contaminants at that point. From what we see and my experience with most people is it's probably the grade of the fertilizer, either the grind size, the particulate matter, because it actually is still soluble. It's just the amount of mixing time required to finally get this in solution went from traditionally being for phosphate and potassium products being, say, 10 minutes on average for most of the products in the industry to being hours, or requiring a different type of mixing system to solutionize it. But a lot of people, when they go through that, they're like, well, it's unreasonable for my operations. A lot of people would see films at the bottom of their tanks if they weren't doing something like that.
So kind of like there could be a combination of more insoluble components or contaminants getting in there, little bits of other minerals and metals, or it just could be that like the grind size is a lot coarser, so things just take longer to dissolve because it's bigger physical chunks.
Yeah, absolutely. Yeah, even down to whether something's a flake or a grind or a prill, all of those things definitely dictate how long it's going to go into solution, or how, when you pour it into solution, how it hits the bottom of the tank or disperses before you've had a chance to mix it can make a big difference.
And I think it's important to recognize that we're not saying that every fertilizer company is going to have problems here. What we're saying is to pay attention.
Yep.
And if you see changes to like mixing and solubility, like problems that you've never had before that just show up out of nowhere, then this is probably a reason why.
One of the big advantages of Front Row is that who our business partners are aligns us with working with some of the largest fertilizer companies in the world, at a minimum North and South America. We have access to materials and purchasing power and the quality of it that I think is pretty unparalleled to some of our other competitors.